All right, here we go again. Chapter 2.1, Domain and Range. Here we go. We're looking at a couple different functions here, but let's talk about domain and what it means for the domain. Domain is the set of all x values. So any x we put in, does it give us a value when we get out? Any real number for which the expression is defined as a real number. Okay, so if we put it in as a real number, does it come out as a real number? Or does it become undefined somehow? If we put in an x value and the function then creates something that's undefined, well, then it's not in the domain. Range is the set of all y values. So we're looking at the y values. And that is determined by the x inputs. So if I put an x in and I produce a y value, well, then I have the range. So the range is the y's. The domain is the x's. All right, let's look at some examples of some classic functions that we see. And we'll also get into some notation about these functions and their domain. Example number one is a basic linear function. We've got f of x is equal to x plus 1. Here's our line. Okay, a linear function means a line, right? And what we see here is that the domain, x, is an element from negative infinity, not including negative infinity. We don't include negative infinity. It's a concept and an idea, not a solid number. To positive infinity, outward bracket. Or we can write that as x is an element of all real numbers. That little symbol means all real numbers. The range for a linear function is y is an element of negative infinity to positive infinity as well. Or the y is as part of the all real number set. Well, why does that happen? Well, for every x I go out to, I will produce a y value. For every x that I go here, I will produce a y value there. So if I have an x here, I get a y value. If I put an x over here, I will eventually get a y value. And if I keep going out to infinity, I keep drawing up and keep drawing down, I will run into that line. And so we have that situation where a line is normally, well, in most cases, it's all real numbers for your domain and range, unless there's some piecewise function going on that we restrict something about the line. I don't know. Example number 2 is a quadratic function. F of x is x squared minus 1. So this is a parabola that's been shifted down 1 unit. And we see here again the domain is x is an element from negative infinity to positive infinity. And the reason for that is because with these arrows, this thing keeps going up and up and up. And we see that for every x we could put in, we would get a y value. However, we're restricted down here in the y category. So look, our range now is y is an element of negative 1 to positive infinity. So again, we may remember this from a previous class, but we always read left to right when we talk about domains. And range, we talk about going bottom to top, right? So that's why we start off here with negative 1 and we go to infinity. Now you'll notice that negative 1 here is included. The bracket is inside, and that's because we actually get a value if we put in negative 0 for x. If we put in 0 as an x there, we get a value of negative 1. So it's a real value. So it has to be included. Okay? A final example is a cubic function. X cubed minus 1, where we have a cubic function that's been shifted down. And we see here that the domain here is x is an element from negative infinity to positive infinity. It's because if I reach out and these x's, I'll either go and hit a y value or I'll come and hit a y value down there. So the domain is all real numbers. Range, again, is also all real numbers. Y is an element of negative infinity to positive infinity. And I challenge you to pause the video and ask yourself the question, why are cubics all real numbers? In what cases could they not be if it were to be? I don't know. Anyway, hope that was interesting for you, and have a great day.